coast to coast in half an hour, solving the physics of hypersonic flight. It's not what you might imagine a hypersonic flight research facility to look like. It's an 8-inch tube. Teresa Carrier-Freethinks reports the Millennium Falcon may fly faster than the speed of light in space, but in an atmosphere, the layer of gases surrounding a planet, the smuggler spaceship was not much faster than a passenger jet, and it turns out entering the atmosphere at super speeds introduces a host of problems. Researchers are working to solve big design challenges of hypersonic flight with a surprisingly small wind tunnel. Imagine hopping on a plane for your morning commute and traveling coast to coast in about 30 minutes, or jetting off to outer space for a honeymoon vacation. Mechanical engineer Chris Cobbs says that may not be too far in the future. He's working on the effects of hypersonic speed on aircraft. In hypersonic flight, aircraft, rockets, or missiles can reach speeds faster than 4,000 miles an hour through the atmosphere. While military uses may be the first obvious application, Combs says the hypersonic travel has a role in civilian travel as well, even in space tourism. He says this is a problem that has to be solved for space access and making spaceflight and even space tourism a very regular thing. To do that well, you've got to understand hypersonic, because anything that comes back to Earth or anything that lands on another planet is going to deal with the hypersonic environment, he says. He says you could have a dinner reservation across the country and come back home in the same amount of time right now it takes you to drive across town and pick up your kids. Hypersonic flight reaches speeds much faster than the speed of sound, roughly over Mach 5, where the physical changes in airflow become significant and the heat intolerable. For example, when a spacecraft or satellite traveling at hypersonic speeds re-enters the atmosphere, it often looks like a glowing ball of fire. This is simply because of friction. In the vacuum of space where there is no atmosphere, friction is a non-issue. Without the resistance of friction from the atmospheric gases, spacecraft can really speed up, reaching hypersonic speeds that currently are unlikely in the Earth's atmosphere. In 2019, Russia shocked the world when it became the first country to deploy a hypersonic nuclear missile. Now the US wants to lead the way in commercial hypersonic travel, but try putting a human in that potential hotbox, and well, no one wants to give it a test drive either. Instead, Combs and his team at the University of Texas, San Antonio, are building a hypersonic wind tunnel scheduled to be completed this month. Hypersonic wind tunnels are rare. The UTSA facility will be one of 3 hypersonic facilities on the US academic campuses that can reach speeds of over Mach 7, but it's not what you might imagine the state-of-the-art facility of hypersonic flight research would look like. The wind tunnel is an 8-inch tube with a vacuum reservoir on one end, and the pressurized pipe creates hypersonic wind flow in a test section as the vacuum pulls air through the tunnel at extreme speeds. Each test lasts for just a fraction of a second, but creates thousands of data points. Combs says not to picture Hot Wheels-esque models in the wind tunnel. He is not building a scaled-down F-35 to test. Instead, he examines a single component like a fin, a wing, or a ramp, and still a lot can be learned about the physics of hypersonic flight from small-scale models. Combs says that running a full-scale test flight on the ground is practically impossible. Aside from the sheer volume of air that you would have to move to mimic hypersonic speed around an aircraft, the friction can fundamentally change the air chemistry and heat up to temperatures that are impossible for a ground facility to handle. Combs' mini wind tunnel reaches 800 degrees Fahrenheit, and that is considered cold when compared to full-scale hypersonic flight. Making things more complex are the presence of shock waves, sharp changes in air pressure created by hypersonic speeds that are strong enough to blow a hole in an aircraft. To study the issue, Combs is testing aircraft material of various roughness and texture in the wind tunnel and to understand their relationship with shock waves. In hypersonic flight, aircraft can reach speeds faster than 4,000 miles an hour. Right now, since our research is not perfect yet, engineers compensate by over-engineering aircraft. For example, the Mars Science Lab, when that landed, it had about 10 times as thick of a heat shield as it needed, Combs said, something NASA learned only after the fact. Building aircraft with those margins is costly, with a small payoff keeping commercial entities out of the game. And Combs says that hypersonic travel is not only for the few that want to go to space, it can also be commonplace for earthbound people. He says, I think what's really relevant is the potential to revolutionize commercial air travel. You could have a dinner reservation across the country, come back home in the same amount of time right now it takes you to drive across town to pick up your kids. Now what's interesting, hypersonic flight experiment, or HEX for short, was the first test flight in the RLV technology demonstration program of the Indian Space Research Organization, ISRO. The demonstration trials will pave the way for two-stage to-orbit TSTO fully reusable launch vehicle. HEX was launched on May 23, 2016. And this is on Collective Spark by Teresa Carey of Freethink. Please leave your comment. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box